Alright, I'm in the Pilot's Handbook of Aeronautical Knowledge. This will be Chapter 4. This will be page 21. So 4-21, Forces in Climbs. For all practical purposes, the wings lift in a steady state normal climb is the same as it is in a steady level flight as at the same airspeed. Although the aircraft's flight path changed when the climb was established, the angle of attack of the wing with respect to the inclined flight path reverts to practically the same values as does the lift. There is an initial momentary change as shown in figure 4-30. During the transition from straight and level flight to a climb, a change in lift occurs when back elevator pressure is first applied. Raising the aircraft's nose increases the angle of attack and momentarily increases the lift. Lift at this moment is now greater than weight and starts the aircraft climbing. After the flight path is stabilized on the upward incline, the angle of attack and lift again revert to about the level flight path, or flight values. If the climb is entered with no change in power setting, the airspeed gradually diminishes because the thrust required to maintain a given airspeed in level flight is insufficient to maintain the same airspeed in the climb. When the flight path is inclined upward, a component of the aircraft's weight acts in the same direction as and parallel to the total drag of the aircraft, thereby increasing the total effective drag. Consequently, the total drag is greater than the power, and the airspeed increases. The reduction in airspeed gradually results in the corresponding decrease in drag until the total drag, including the component of the weight acting in the same direction, equals the thrust. Due to momentum, the change in airspeed is gradual, varying considerably with differences in actual size, weight, total drag, and other factors. Consequently, the total drag is greater than the thrust and the airspeed decreases. Generally, the forces of thrust and drag and lift and weight again become balanced when the airspeed stabilizes, but a value lower than in straight and level flight at the same power setting. Since the aircraft's weight is acting not only downward but rearward with drag, while in a climb, additional power is required to maintain the same airspeed as in level flight. The amount of power depends on the angle of climb. When the climb is established steep enough that there is insufficient power available, a slower speed results. The thrust required for a stabilized climb equals drag plus a percentage of weight dependent on the angle of climb. For example, a 10-degree climb would require thrust to equal drag plus 70% of the weight. To climb straight up would require thrust to equal all of the weight and drag. Therefore, the angle of climb for climb performance is dependent on the amount of excess power available to overcome a portion of the weight. Note that aircraft are able to sustain a climb due to excess thrust. When the excess thrust is gone, the aircraft is no longer able to climb. At this point, the aircraft has reached its absolute ceiling. Alright, next one is forces in descents. Forces in descents. As in climbs, the forces which act on the aircraft go through definite changes when a descent is entered from straight and level flight. As in climbs, the forces which act on the aircraft go through definite changes when a descent is entered from straight and level flight. For the following example, the aircraft is descending at the same power as used in straight and level flight. As forward pressure is applied to the control yoke to initiate the descent, the angle of attack is decreased momentarily. Initially, the momentum of the aircraft causes the aircraft to briefly continue along the same flight path. For this instant, the angle of attack decreases, causing the total lift to decrease. With weight now being greater than lift, the aircraft begins to descend. At the same time, the flight path goes from level to descending flight path. Do not confuse a reduction in lift with the inability to generate sufficient lift to maintain level flight. The flight path is being manipulated with available thrust in reserve and with the elevator. To descend at the same airspeed as used in straight and level flight, the power must be reduced as the descent is entered. The component of weight acting forward along the flight path increases as the angle of the rate of descent increases, and conversely decreases as the angle of rate of descent decreases. The component of weight acting forward along the flight path increases as the angle of rate of descent increases, and conversely decreases as the angle of rate of descent decreases. Alright, so we'll hold off right there. That's page 421 and 422. Let's see what we can call that. That's forces in climbs and forces in descents. See ya.